Hi, everyone. I'm going to start our video series. I hope to do a few of these for you to prepare better for your upcoming exam. So this one is on recursion, and I think it's going to be something that you can practice along with. So whenever I say something, feel free to pause the video and then go ahead and look at it or try to get more deeper into it, okay? Okay, I will assume that you know how to define a function and to call one. I decided to choose recursion because I think for many new computer science students, the concept of recursive programming is often confusing. And so it's okay if you're still learning and if you prefer iterations of recursion, okay? So first, let's start by understanding what recursion is. And the most common definition you will see is that a recursive function is one that calls itself. So in this example, you will see that I've defined a recursive function, recurse, and there's something that it does. And within the function itself, I call recurse again, the highlighted part in yellow. And outside the function, I'm calling it one more time just so I get to test it out, and I'm calling it from my main program. Okay. Now, when a function calls itself, we do need a strategy to stop calling the function, okay? And this is the base case. Every recursive function needs to have a base case, something for you to remember, super important. And this base case can be just one, or yes, you can also have more than one base case. And this is typically done with an if condition check. So in this one, you'll see that I check with if there is some condition that I'm checking, and this is the base case, and I'm returning a value back. I'm not calling the recursive function again if the base case is true. Now, I thought I'll get you to think about recursion in terms of 5 steps. Okay, so first one is to determine the parameters that trigger the base case or the recursive case. If you're doing one of those grade scope sheets that I gave you, so that would be your, n in your definition of a function. Most often this parameter is passed to the function, but not always, okay? And we'll look at examples upcoming about when it's not passed. The second step you need to do is you need to determine the base case. Super important. The third, determine the set of subproblems. So when will the function call itself? That is your recursive case, the else part of your if check for the base case. Okay. The fourth step is to actually do the check. Use your if statement to check to see if the current value that you're processing from your step 1 matches the base case. If so, you process and return the value. Step 5, if not, what do? You run the algorithm on the subproblem. So you call the function again, and your results could typically be a combination of the return values, or it could just be a calculation or something to that effect. Okay, so you return something even from your recursive case. Okay, let's look at an example. Now, you would have seen that I have these stars on my slides at the side, and so that is one example that I wanted to show you of the recursive function. Okay, in this case, you'll notice I have about 30 stars, and there's 30 rows of stars as well. And you'll see that the stars go all the way from 30 down to 29, 28, and all the way down to 1. So before even we start looking at the steps, look at the output and think about what is it that repeats itself. So in this case, the printing of the stars on each line repeats itself. Yes, it's true that each line has a different number of stars, and that actually determines your parameter n. Okay, so let's look at our 5 steps and try to kind of make these a little more understandable. So the first one is to determine the parameters that trigger the base case. So let's start with the number of stars to print. That's what's changing, right? In every line. So you define your function def rec stars. I'm just calling it rec stars, recursive stars. And I take an argument n. Okay, that's the number of stars to print. Next, step 2 was to determine the base case. Here, the base case is when n equals 0. Why? Why did I pick that? Well, you could pick n equals 1, but I picked n equals 0 because when n equals 0, you print nothing. You just return, right? In every other case, you still continue to print, but when n equals 0, you just return. So I picked that as my base case. Now, step 3 is, you guessed it, to pick the recursive case. So in the recursive case, in the subproblem, what do? You actually need to print the star. So I'm going to put a loop in. So for I in range 0 to n, remember n is the parameter that got just passed. So my for loop now looks at for I in range 0 to n, because I'm going to print 0 to n minus 1 stars, which means I'm printing n stars. And then we don't want it to go to a new line. So remember, we always added the end. So when you say end equals nothing, you actually prevent it from adding a new line to the print statement. Okay. Now, our next step was to actually have that if condition. And the if condition in this case is simple. I just said if n equals 0, I want it to return back. So that would be our if condition. And our final step would be to run the algorithm on the subproblem and return something else and call the function again. So what do we do every time? Every time there is one less star. So when we call the function, when we call the recursive function, in the recursive case, so after the for loop, we actually have to pass one less star. So I'm passing n minus 1, and it seemed like it would work with just that, but then you notice that every recursive call starts on a new line. And so I'm adding an empty print statement so that every time the function is called, it actually goes to a new line. Okay. Now, let's run this all together. So here you'll see my function. I called it outside with rec stars 30. And you'll see that the base case is n equals 0, return, do nothing. And if n is not 0, so all the way from 30, 29, 28 to 1, I actually print stars. And when I finish printing a line of stars of the range 0 to n, I add a new line and I call the recursive function again. Okay, I hope this made sense, and I'll share some more examples with you shortly.